Hi, everyone, and welcome to our April SciDome at Home program. My name is Dr. Meghan Federer, and I will be exploring the sky with you tonight and exploring Earth as well as we celebrate a little bit early for Earth Day this month. We'll get to see a little bit about Earth and learn a few things in comparison to our neighbor planets. And we'd love to also have you join us in the SciDome to explore Earth more this month as we feature birth of planet Earth and habit and dynamic Earth as we move forward into the summer. You should see the sky slowly setting. We've moved time forward a little bit as we look to the evening sky. It's set for today's date, and time's moving a little bit quicker than normal. So we'll get to see the beautiful sunset here, hopefully, and moving into some of our sky view. If you look closely to maybe your southwest sky, we're facing to the south here. If you face to your southwest sky and look up almost at the top, you'll actually see the little sliver of the moon that's visible. Now our sky is staying light for quite a bit longer than maybe we're used to right now. It seems like that the days are getting longer really quickly after the winter. And so it actually does take quite a while for us to get to a truly dark sky, but you're going to start to see a few little peeps of light popping out, especially towards that southern band where we have the bright streak of the Milky Way stars popping up. Now, on my view, I'm starting to see a couple pop through. So I hope that as the sun gets a little bit further down the horizon, you'll start to see some, especially to the south. And I'll pull up one of those brightest specks that will be the first star that you'll see. And there it is, Sirius. We're starting to see more and more pop out into view, including some of the familiar winter stars that you'll recognize. So Sirius might be the first one that you see because it is the brightest star in our sky, twice as massive as our sun and quite close to us, so quite bright. It's only 8.6 light years away. But as the as the sky darkens, you'll start to see some of those other large, bright beacons towards the southern sky, or fading winter constellations, including Betelgeuse up in the shoulder of Orion and Rigel in the foot. Now you can see Orion there shining off to the southwestern sky quite brightly now. And we'll pull Orion up just to help you find it if you haven't seen it yet. And now here we are getting to a nice darker view, and it's 8:30 even before we're starting to see a nice dark view of that sky. Now, I mentioned a few of the stars that we can see, but there's obviously a lot more up there. And we're going to focus a little bit on our southern view here for a moment while we take a look at what else will come out in our kind of early evening sky. So it's a little chilly out tonight, but as we get into the warmer weather, it can be fun to go out and take a look at what we can see as the sky is ever changing from season to season. So we'll go ahead and pause here. We're only at about 9 p.m. So even if you have family members or kiddos that maybe want to take a look and get inspired by what they can see in the sky and what we're exploring, it's not too late to see some beautiful sights. So we'll start off first by taking a look at just the suite of constellations that are kind of visible here from the southern sky. And if you haven't really looked at constellations before, some of these might be new to you, or maybe they're just a little bit more difficult to find, because the way we think of constellations, you know, we look for those bright stars, something, an indicator for us to be able to find the pattern, but often even the pattern maybe doesn't represent the name that astronomers have given. But I like to pull it up slowly so we can kind of see some of the patterns that are recognized and maybe ones that are familiar, or maybe things that you have found. Now, just to reiterate, we did have Sirius right here, that bright beacon, and here over here is Orion with the shoulder marking Betelgeuse and Rigel, so that we know we've got some bright stars that can help us find some other points. Now, Sirius is the nose of the constellation Canis Major, right there, Canis Major. And Canis Major is the great dog. Now, Canis Major is also a prominent winter constellation, and you can see that it's going to be setting soon with Orion, but it's still highly visible for quite a few weeks in our early skies as we start to see our spring stars really rising into view for the early evening viewing. Now, one of the things that you'll recognize often in the patterns and labels of constellation is that if there is a major, that there's likely a minor. And so we can pull Canis Minor up as well, a small little constellation just above Canis Major. Much more difficult to find, but it does have one bright beacon that we can recognize. The lower of the two stars right there. Procyon is quite visible. If you can find the Sirius and Betelgeuse, you can usually find the beacon that is in Canis Minor. Now let's pull up a few additional pieces as we look to the sky. I wanted to highlight an interesting one that's coming into view, and that is Hydra. I'll give you a moment to see if you can find it, but Hydra is the largest constellation of the 88 recognized astronomical constellations. So Hydra is, if you know Greek mythology, a many-headed beast. And there we can pull up some of our illustrations to take a look. And so it takes up a large region of that space, largest constellation. Some of the other ones that you'll be able to identify and view as we move through our spring season and into summer, you can see that many of the zodiac constellations are in view as they're always along that ecliptic line that helps us kind of track the path and movement of the sun and planets that are in orbit around our sun. We'll pull that ecliptic line up and you can see that there. You'll notice that the ecliptic actually passes through all of those constellations that are associated with the zodiac, which is what early astronomers used to place a little bit higher prominence on them as they were recognizing the movement of the stars, the wandering stars, what became later recognized as the planets that were our neighbors in our solar system. So some of our prominent spring constellations include those like Cancer and Leo, some interesting stars that you can find, and Virgo rising off to the southeast. A great constellation to be able to look for due to the interesting sites there located in the regions of Virgo. Now, if you're looking at some of these names and wondering what they are, you might be confused as to why we have things like Monoceros and Hydra, but we also have what look to be scientific instruments in the southern sky. And that is true across our sky. There's a great mixture of constellations, names, and shapes that are associated with them. And that's due to the fact that constellations were not only named and discovered by ancient astronomers, but also as later scientists explored further around the world and recognized new patterns. And we had many different astronomers naming the same stars in different ways. And so slowly, there became a unified perception of the sky that astronomers use to communicate around the globe. And so some of our constellations are tools, some of them are mythical creatures, some of them represent ancient stories, Roman goddesses and gods, Greek gods and goddesses, anything really can be found up in the stars. So now that we've taken a look here, we'll go ahead and focus in on a couple other things that we can recognize in our sky. I had mentioned that ecliptic line earlier, the ecliptic being the target that we can use as a way of trying to find out where other planets might be from our view here on Earth. And the reason that we can use this ecliptic view is because we are orbiting our own sun. So we're one of several planets, several inner planets. We're one of 4 inner planets, and there are 4 outer planets that are orbiting the sun. And if we take a look at the solar system, we can kind of get a sense for how the planets move about the sun and why we might be able to predict those planes. So right here is just our inner solar system. And you can see Mercury, Venus, Earth, and Mars all in orbit around our star, the sun. And then following that, circling it, the asteroid belt, along with the dwarf planet Ceres. And we have to go quite a bit further out to be able to get to our outer planets, but we can see our outer solar system as well and look at it in view in the orbits around the sun. Now, the one thing that this graphic doesn't really show you is what I meant about how we're in the same plane. So right here, you can draw circles like this in many different ways, and they won't actually be in the same plane, which means kind of like on the same piece of paper, if you were to draw all the orbits of our planets. And we can see that if we take a look from a side view. So if we look here, and I'll try to get it to move up a little bit. Take a look at it. Well, what we can see here is some views of our solar system orbits. And we can see that there are the 8 planets that orbit the solar system all within that plane, but we also have that view of the dwarf planets and how they don't really line up with that of the rest of our solar system. And we can see that maybe a little bit better here. I've got it to move now. It was going a little crazy before. But here now you can see how they're not quite in the same angle. We've zoomed way out and we can see some of those lines and how they might be coming off kilter, off the paper that is our solar system. And that is what the ecliptic line helps us track when we're back on our home planet, taking a look at the sky. So we can see that here, bringing that ecliptic line back up, that really helps us track that movement. That represents that orbital plane. And so anything that orbits our sun is actually going to be found along this line. Now, right now, a lot of our planets are actually visible earlier in our sky, so often even in the daytime. There's not a lot of great planet viewing right now. And if we scan our sky looking around for them, we're going to find one right there. You can see popping up, Mars, off to that southwestern to western sky. So it's already moving on towards setting. But if we move time backwards a little bit, even if we just want to jump back to, let's say, 6:30, and it'll be bright again, we can see some more planets coming into view. Now, they're not ones that we can go outside and take a look at, but it's really interesting, I think, to use this tool to confirm the movement of planets and see where they are in their orbits and trajectories around the star. So we can view all of them, depending on the season, right here from our own backyard. So we'll go ahead and move back to our evening sky so we can take a look at Mars. Now, we did say we were going to talk a little bit about Earth today, and we are. We're going to learn a little bit about what makes Earth so unique, how it compares to its sister planets. And one way to do that is to take a look at the neighboring planet that has fascinated viewers and scientists for so long. So while we're getting to our dark sky here, why don't we think about what we know about Earth? Some of the things that we know about Earth are from our own experiences here. We've explored Earth But there are areas that we haven't explored. There's areas that we have no more knowledge of than we do of areas of outer space. And some of those are what we consider to be like the deepest points of Earth, the deepest trenches, and sometimes the highest mountain peaks that we don't necessarily know a lot about, and how ecosystems or life interact in those habitats. But what's interesting is that despite the vast differences in height, whether we're talking about the tallest mountain, which the tallest mountain above sea level is Mount Everest, but it's not actually the tallest point on Earth from the core, and we'll get to that in a minute. And the deepest trenches, they're still actually dwarfed in comparison to the tallest mountain and trenches in the solar system, which are all actually found on our neighboring planet there, Mars. So if we go take a look at Mars, we'll see the red planet has a lot of geological features that are interesting, but the one that is relevant to what we're looking at right here is called Olympus Mons. We can mark it right there. You can see that almost dimple like structure that you're seeing there on the surface, but it's not a dimple, it's actually an extremely large and tall volcano. And so it holds the honor of being the highest point in our solar system. As we take a look at Earth to see what I meant by why perhaps the highest point on Earth from the center of the Earth is not Mount Everest, let's take a look at our planet. Now, Earth, as seen here, is quite beautiful, and we can see that it's a typical model of Earth, right? We can see our atmosphere, the clouds, the ocean, and the continents kind of coming into view in greens and browns. And it's often referred to as the blue marble because when we first got our view of the planet during the Apollo missions, the way it was described is overwhelmingly blue due to the amount of oceans that were visible with the little specks. So it's a little blue and green marble compared to what a lot of our other planets in our solar system look like. But it also gives us a sense that the Earth, being a spherical model, maybe is a perfect circle. And it's actually not. What we see with Earth is that the radius of the Earth at the equator, the radius of the Earth at the equator being around 3,900 or so miles, but it's not spherical because just like other bodies in our solar system, the rotational pattern actually causes the center of the Earth to bulge out. We've got some little love handles on Earth. And so we have a little bit of a difference of around 13 or so miles between the polar radius and the actual equatorial radius. And so we've got that little donut-shaped bulge that actually is creating it to be not a perfect sphere. And we see that not just at Earth, but in all of our planets and in our sun. So in all of our objects that rotate. Now, one of the things that's visible here as well is our moon, but this is a little bit deceptive to see our moon here in this view. So we're going to go to a different look, and I'm going to be curious if you can find the moon in the sky from this next view of Earth. We've zoomed out a little bit just so that we could see a full Earth, a little bit of Earth shine from the sun, but it's not moving, and the moon is not moving either, so we should be able to find it. But unlike in our last view, the moon is not as visible. You might be wondering why. Well, one of the things that we can do is change the size of objects to make it easier to find them, and that's what we had done in the last views. But that means that the viewing of the moon is a little bit inflated. And we often think that the moon must be huge. And it is. It's not that it's a small object. It's the 5th largest satellite in our solar system, but it seems like it's so big and so close to us because of how we view it in our sky. But it's actually quite far away. You may have seen images that show that the diameters of our solar system, if we lined up all of the planets between the Earth and the Moon, every single one of them would fit edge to edge. So there's a vast difference between the Earth and the Moon, but also in sense of size. The Moon is actually in view, like I mentioned, right there, far to the left from your view, but it's just not magnified. And so if we magnify it a little bit to be able to see it better, you'll see that it looks similar to what we saw in the previous one. So it's a bit deceptive, these views of our space where we're looking at the size and scale compared to the planet and the objects surrounding it. And it's important to recognize that we can play around with that and get a sense of the true size and scale. Now, speaking of size and scale, it's often really interesting to take a look at the Earth relative to the other planets to see how big it really is. You know, how big is Earth and what interesting things do we know about Earth? It's the third from the sun, we know that. And it's the only planet known to have an atmosphere that contains free oxygen, oceans of water on its surface. We know, of course, harboring life. And it's the fifth largest in our solar system. It's only smaller than our four outer gas giants, and it's the largest of the three rocky inner planets, although just marginally relative to Venus. So let's take a look at some of those other planets where we can see them. First up, we do have Mercury, a rocky small planet closest to the sun. Venus, a rocky planet, but with such a thick atmosphere that it actually resembles quite a bit our gas giants because we can't see through the atmosphere. Following Earth comes Mars with those highest peaks and deepest trenches. As we travel further to the outer solar system, we'll get to see some of our giants. Jupiter, the most massive in our solar system. Now, the gas giant's composition, too, is quite a bit different than that of the inner planets, with Jupiter and Saturn being comprised of primarily helium and hydrogen, relative to the Earth's atmosphere is actually about 78% nitrogen and 21% oxygen with trace amounts of other elements. So we've got a very different gaseous composition. Our last planet's Uranus and then Neptune, the most distant of our icy gas giants. Now, this may not have given us a sense of scale in the same way that we can do it if we compare all of the planets side by side. So why don't we take a look at what we can do there? Let's enjoy a comparison of the size and scale of our planets. All right, it's loading here. On your view, you'll see that we've got 4 small dots that are appearing on both sides, upper and lower, and you can just take a look at one of them. But we're looking at Mercury, Venus, Earth, and Mars. relative to each other. So you can see the two center points of Earth and Venus are actually very close in scale, despite the fact that Earth is just a little bit larger. If we then look at the scale of our gas giants compared to our inner planets, we can see how vast Jupiter and Saturn, Uranus and Neptune actually are relative to our inner rocky terrestrial planets. Yet despite that, they're all, even the smallest of our rocky planets, Mercury, followed by Mars at about 1/3 the size of Earth, they all dwarf our dwarf planets, right? Pluto, Eris, and so forth. One model of them included there at the end. And they all dwarf, of course, all of the natural satellites, the moons that orbit the different planets. Earth only has our one moon, the moon, but there are moons that orbit many of our other planets as well. Now, stellar, our size and scale would be nothing if we don't also include our stellar component of our solar system, and there we can see it truly to scale. So if we know that Earth would really be as large as that third circle in, that would be the size of our sun. Now we mentioned chemical composition of our atmosphere a minute ago, but the composition of the planet itself also is something to consider. And all of the chemical composition is something that we're actually exploring, not just here on Earth, but also on our other planets, especially our work that looks at Mars. Get you back to Earth here so we can think about that. Now our northern sky, as we look here off to the distance, is going to be a little bit different than our southern sky. The stars that we view to the north, while you can, there's some movement that we can see, by and large, the movement is almost circular, and that has to do with how the Earth rotates on its axis. So let's take a look at this because it's quite fun to be able to see that point upon which the Earth rotates, and that represents our axial pole. And if we pull up our constellations again for a minute, you can actually see this really clearly. You can see the Earth there with its rotation, seemingly around a point in space. And that point in space is none other than a specific star that we sometimes refer to as our North Star. We'll slow time down here for a minute while we're taking a look here. But that North Star is actually in line with the Earth axial poles. So when we think about the Earth axis and the North and South Pole, we can use some grids to kind of help us find what we're looking for. See if I can get the right grid pulled up here. There you go. So there's the marker that's telling you that the North celestial pole above the Earth is right there, located just about where Polaris is, and that is why Polaris appears to be fixed in our sky. It's kind of like if we drew a line from the North Pole out into space. When it reaches the point where Polaris is, it almost directly intersects with it. Now, if we wanted to see that a little bit more clearly, oops, my apologies, we can pull up a grid for us to take a look at. There we go. The grid point that's marking that pole. Now you might be wondering why the North Pole isn't just directly above you. Well, then in our sky, why is the North Celestial Pole not just at our zenith? Well, because our point of view on Earth is still fixed and locked with what we are rotating on. And so the northern axial point appears to us at this degree above horizon because of where we are located on Earth. So our latitude location actually will correspond with the degrees above horizon that Polaris is located. And so if we're curious about what our location is, you can see where we're located here on this view. And you can also travel like to the North Pole. And if you travel to the North Pole, you would see that the stars just move in a circle directly around you. And that is also what results in the phenomenon that we recognize that sometimes the sun never rises and sometimes it never sets. So we can take a look at a real fast motion here, where we are recognizing that it's constant daylight and the sun coming up above the horizon finally. So even though the sun wasn't above the horizon, we still had that daylight, and then the sun will go later in the season below the horizon, and slowly it will go to the darkness. So the 6 months of light and 6 months of darkness are actually a common way that we describe what happens at the poles. We'll return to our sky. And with that, if there are any questions, I would be happy to take a look and see if there are questions that you do have about anything that we could see. You are welcome to submit questions in the chat box or via Q&A. I hope you enjoyed seeing a little bit of our sky, a small window into the universe above us, and that you can go outside this evening or this week when we have a clearer view, unless you get a brief window in the clouds, and get to explore and observe some of the sights above you. I'm not seeing anything come in, so with that, I will say thank you for joining me, and I will see you next time.